Next step that you're supposed to do is you have to prepare the protein molecule. Before we can go and create the PDBQT file, we have to change something in the PDB format, okay, in the file that we have downloaded, because there will be ligands bound. So I'm going to open it with Chimera. Please open up Chimera. It takes some time to open, so I will suggest you try to open it and keep it. We have this Chimera stuff opened over here, and once you open your file, you will see something like this. Okay. Now, normally by default there is a black background, which I change to white, and then I'll teach you that in a moment. Right now, let's go and do our stuff. Right, whatever we came for. So you can look at the structure and try to understand it. This is good. Looks like a beta barrel structure. And yeah, you have your molecule, which is over here. This is biotin bound, and these are the amino acids which are popped up shown over here. These are the amino acids which are interacting with this particular structure of biotin, and you can see three dots over here, which is water molecule. So what we are going to do, we are going to go to the step, and please, all of you, if you have opened, then I can start this, because most of you might that is not mentioned in the protocol. So please learn. There are two things: select and then action. There are These are two very important tabs on your Chimera, which you are going to require most of the times. Select, without selecting something, you cannot do an action on that. So in this, first is select. Now here we want to take away, we have to remove biotin, and we have to remove water. So we go to select, and we go to, there are options of what you want to select. So many options are there. In chains, there is only one chain. Chemistry, in under chemistry, you will have carbon, nitrogen, oxygen, other atoms, and functional groups. If you want to select, if you have any ideal atom type that you want to select, all those options are available. But usually, you will not require chemistry any moment. You would require either chain, or you would require residue most of the times. Structure sometimes. So we go to residues, and I'm going to select all non-standard, okay, which will select biotin as well as water. All non-standard. If you see here, uh, there is a green line, green vibrant line, fluorescent green line around those molecules which are selected. Anytime you select anything in Chimera, there will be this line that comes up, okay, around that particular region. So what I am going to do, I have selected this. Next thing is I press on action. I click on atoms and bonds, and in that the last option is delete. I click on delete. Okay. Now you can see here, this is gone. The water molecules are gone. Biotin is gone. Okay. Now I'm going to save this without the water molecule and without the biotin. So I am going to save this as PDB. So when you click on save PDB, you will have an option of where to save. This is something very important in Chimera. You have to have the folder name. Now I don't have the folder name here. How do you change it? Learn this. I am going to teach you a very you know shortcut method. You go to your folder, click on the address bar over here, not on the name. You click beside that an empty space here. This is the address bar of your folder. Click there. So everything will be selected. The whole detail of that folder is selected. I mean, the path is selected. Click on Control C. You can select that. Okay. And actually, you have an option of copy path. So, but I'm not getting it. I don't know why. You can copy path from here. Yeah, here. So you can copy path from here also. Uh, that's another option. You can just copy the path, and then you go back. I go back to this place where folder option is written in Chimera. Where did this come from? This came from file save pdb. So this option came. I have pasted the address here. Press enter. Nothing comes. Okay, this is mistake. There are double quotes. I have to take off the double quote over here. So I can see it's in the folder right now. You can see this is docking fluid, the folder, and this is the name of the. This is where PDB format is saved. So what we are going to do, I'm going to save it at cln.pdb. I have just cln is just going to give me an identification. It's cleaned molecule. I mean, I have just taken away the biotin and water molecule from that, and I'm going to save it with a different name. I'm not going to touch the original file. I'm going to leave the original file just like that, and you can actually overwrite. But no, we are not. I'm not going to do that. I will not suggest you to do that either. Do not select any of these things. Not required. Uh, just click on add. Yeah, add pdb suffix if none given. But I I will suggest always write the extension. Okay, suffix. Now this is in pdb format that we are saving. So write pdb and then save it. Now I'll want to show you that it is saved over there. You can see this is here. Strep cln.pdb. It is saved. Okay. And if I want to see how it looks like, what I'll do is I will close this session. It's closed, and I will open it. I can open it from here because it's actually it will come here. Okay. The name will come here. If I click on this, the file will open up. These are the shortcuts. But no, I'm going to browse. So I'll browse it, and this will be once you have saved the folder, once opened the folder, it is always going to open at that same location. So uh, I have this step cln.pdb. Select that, click on it, and you can see your protein has just come here. Okay. Now you see you don't see any ligand over here. If you want, you can cross check. Go to select, go to residues. You will see only amino acids. Okay, there's nothing else over here. So yeah, we successfully cleared everything that was not required. Now we close the session here. Mm, We'll go back to biotin. Now for biotin, we have to use open label for that. No. When you click on open label, when you open open label, I hope you already have installed it. So once you have the open label opened, click on the input format over here and go down to find out SDF, which is MDL mole format. So I select that. Okay, and in output we go to PDBQT format. Please see that all of you are having this option, PDBQT option over here in the output format. If anybody is not having that format, please let me know. That is an essential part. That's why I want you to see whether PDBQT format is available in your open Babel version or not. So please check it out. We are starting here again in the SDF format. Now click here and we go to I'm going to do this here. This is where docking fluid is the folder that I have created. And this biotin is my molecule, biotin.stf. I click there, open it. I will also select this option of delete hydrogens. Some excess hydrogens are usually added in these structures. I'll just take them off from here. Delete hydrogen, make implicit option. I will check. You have to select that, and in the output, you have to write the name of the file that I want as the PDBQT. So I'm going to write biotin. Now SDF is called. So I just change it PDBQT, and I will save it like this. Now nothing, just click on convert. So one molecule is converted and PDBQT format of my ligand is created, biotin is created. So let's see where it is. Here it is. Biotin.pdbqt is here. Okay. So it's done. The function of open label is done. See, as I was telling you, you can look at this here. You have this XYZ coordinate, van der Waals forces, electric charges, Q type, all those things are mentioned here for every single atom that is there. So if there is a sulfur over here, the X coordinate, Y coordinate, Z coordinate, everything is mentioned over here. And then carbon, for each and every single atom in the molecule, there is a specific location in XYZ coordinate. So this is a three-dimensional structure. If you want, you can also have a look at biotin.pdbqt. I will show it to you. Two files of. So from here, what is this? So I have to choose what file format. I'll just take PDB format here. You don't need to do this. I'm just doing it to show it to you. This is a three-dimensional structure of biotin. Nice. So I just close this. It is not required right now. Okay, what's the next step? The next step is preparation of ligand is done. Now we had started with this uh, retrieving, and then in the retrieving itself we have created and converted to PDBQT. So this is done here. Next step, prepare the protein molecule for docking. Now let's do that. On your desktop, because you have all installed Autodock, so on your desktop you will have Autodock tool, something like this. Please double click on that, open it. It might take some time to open.